Okay.
Okay, so for number 5 question at the bottom, it just it gives us the 8 variables outcomes for each roll. Calculate the probability of rolling a number greater than 5.
Okay.
So
I did it already.
for me, I put a fraction, because I figure since there's 8 numbers and since only 3 of them are greater than 5, it'd be 3 over 8.
Yes.
That's what I got.
And I mean,
which equals 0.375.
Yeah.
And then the last one is calculate the probability of not getting a number, which made me think for a minute. Greater than 5. So it was.
So I got 5 over 8. 5 out of 8.
Right.
Yeah, I got 5 out of 8 too.
So it's 5, including the 5 and the numbers all less than that, right?
Mm-hmm. Yeah.
Yes.
5 over 8, 0.625. Okay. So now we have to do our group quiz.
Okay.
At least those were easy.
Yes. Tell him he's being recorded and your instructor will see all of that.
I know.
I'll go ahead and read the questions if we want to do that.
I'm having trouble with mine to come up. Come on. Hold on. I gotta tell these kids to be quiet. Hold on. Okay. Oh no. Okay.
What?
No, we're still on.
Oh.
I thought it ruined my recording. I'm like, no, please no. Okay. Here's our group meeting quiz. Are you guys ready?
Yep, I have mine up.
I'm a little nervous. At least we get.
Me too.
Let's do it 2 times.
Yes.
We do it together. I'm just kidding.
Ethan knows what he's doing, so that's the good thing. I didn't. Okay. Okay, so here we are.
Okay.
Said give all of our probability answers as decimals. 0.1, 2, 3, 4. Do not give probability answers as percents. Okay.
All right. Okay, so let me go ahead and read them.
Yes.
Okay, I'll start with use the following information. Okay, use the following information to answer the next 3 problems. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportions of people in the population of the United States with each of these blood types is summarized in the following table. Can you see the table there?
Yep.
Okay, so it said, question 3 says, the blood types and their proportions given in the table above define a probability distribution, true or false? I would say true, but I don't know why I would say true. That's,
Well, let's see. So, do all those numbers add up to 100?
oh, well, that we could probably do that, huh? Point
Because it would have to add up to 100.
40.
I don't think those numbers.
Yes, it does add up to 1.
It does?
Yes.
Yes, it does. So, yes, that would be true, correct? Are we correct, Keith?
So, yeah, because it lies within the variable. I mean, I think it goes from 0 to 1, and if it lies between there, it's a probability distribution, right?
Right, because it adds up to 100, so it can't go over 100%. It has to add up to that, right?
Mm-hmm.
Yeah.
That's right. Okay.
Okay.
Mm-hmm.
All right. Number 4. What is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places.
Well, the point.
The probability.
Says, so you would just add those. So
45?
go ahead, Keith.
Does it, is it just 0.45? Because, I mean, what you're asking divided by the total. I mean, the total by 1.
Round to 2 decimal places. So, it's, well, it already tells us like the percentage. So I don't, so we have to divide it by how many, right? Because there's 4 different blood types. So how do you,
Yeah.
so do you just divide 0.45 divided by 4? Is that what we do?
It gives you a better answer than just the same number you started with. So
Well, so it's 0.45, I think, divided by 4. That's, I don't know. What does that give us?
it equals 0.1125.
Okay.
And the
I think, so does he only want 0.11? Is that what our answer is supposed to be?
What did you come up with, Keith?
well, I said it was 0.35, but thinking about it seems too easy if you came up with the number that you started with. Because the way I was thinking is that what is the probability? And in the last question that we went over, we said what is the probability that the number is greater than 5? There's 8 possible numbers to choose from, and only 3 of them are greater than 5. So it's 3 over 8. This one, it says, what's the probability of randomly selected in the United States? Oh, so I feel like Lisa is right because there's only 4 people.
So is it 0.11 or, because he says round to decimal places. So it's 0.13. It would be 0.12? No, it would be 0.11.
I feel like you're right because you took 0.45, which is the probability.
Right, divided by the 4 of them. I hope it's right. I mean,
So
we
what?
can take the quiz again if we.
So what do we come up with? 0.11?
Yes.
Okay.
Because it wants us to round to 2 decimal. That's my guess after doing the assignment. So
Because
That makes-
that's what I come up with was 0.1125. That's
yes,
what I got up on
but I
mine.
think he just wants us to do it to 0.11. So, okay, so let's see. Now what are we looking for? We're on 6. So
We're on
this,
5.
oh, did we
On
skip
question, yeah.
one?
So
Okay.
it says, question 5 says, what is the probability that a randomly selected person will not have type O blood? Round to 2 decimal places.
So, sorry
Right.
guys, it's a little rowdy at my house.
No, you're fine.
Okay, okay.
I think we do the same thing as the first one. Instead of doing the 0.45 divided by 4, we
Right,
do the 0.4 plus 0.11 and plus 0.04 because O's aren't the O's. And we
Right.
still
we're gonna still divide it by 4.
divided by 4, yeah.
Okay, so what do you get then? So you're adding A, B, and AB together and then dividing it by 4.
So I get 0.1375 and it's 2 decimal places. The 7 rounds up to
4.
4.
So 0.14 then.
That's 0.14. That's what I got.
Okay, good.
okay.
Hey, that's good. So the next ones, use the following to answer the next 2 questions. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to 2 specimens derived from a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of the specimen. 7 bowels containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified with the cancer. If the dogs guess at random, what is the probability they will correctly identify the dish containing the specimen from the bladder cancer patient? So there's 7 altogether.
Yeah.
Bold. Yeah.
Okay, and there's 6 of them who didn't have it.
That means one of them did.
So it's going to be 1. Is it going to be 1/7? No, 1/7,
Yes.
which equals what? I'm gonna get. I need a calculator by me.
It equals
It equals 0.142857. Is that what you guys got?
Yep. That's what I got.
Long numbers, so it's really
Yeah.
1.4 then.
So it wants 3 decimal places. So 1.143.
Okay. 0.143. Okay. Oops. If we don't put the decimal, we're going to get it wrong. Okay. So now we're on 7.
Oh, I guess I should put my answer in instead of just write it down.
Yeah. Good point. This is really loud and annoying. My cat, I need to move out. Okay. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate?
Okay. This prevents strong
It only picked it out of 22 times out of 54 times. So that's not a very high probability that it's.
Not even half. I mean, to be strong evidence, I feel like it needs to be at least 3/4 or above, and that'd be around the 40 mark.
Right. So there
And
is,
if you divide 22 into 54, I got 0.4074. It just keeps going.
yeah, so it wouldn't be enough, or at least 50% or higher.
So
So
there's
I
no.
would say no, there's too little evidence that it could really detect that. Okay.
I
Use
feel
the
like
following. Sorry.
we're fine.
Is that the right answer, Keith, you think?
Like, I just want to say I feel like it's right.
Okay, you go ahead and read this one.
Okay. Use the following information to answer the next 3 questions. M&Ms, I love them. They're so good. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. And there's 1, 2, 3, 4, 5, 6. But green has a number scribbled out.
I think so. No, don't count any for that. Don't count that. Or do we still count it, but it doesn't have any.
Is it wanting us to look for the what that number would be for the green?
I feel like it's a trick question.
No, I feel like it's still going out of 1 because all answers lead up to 1. So if we add the rest of them together and then subtract from 1, we should get the probability of green.
Oh, I see. You're absolutely correct, Keith.
So he wants us to think a little bit.
Yeah, outside the box here. I'm glad you brought that up because
So I come up with 0.16.
You're a fast button presser.
I'm not that fast at, I guess I have to add it all out.
And you said you got 0.16?
Uh-huh. So would that just be that the probability of getting the green would be 0.16? Or is 0.16 our answer?
0.16 is just for green. We
Okay.
haven't went on to yet.
So, because we still have to divide, so green is 0.16, but it says what's the probability of drawing
Red.
red. So we're going to divide, are we going to divide 0.13 divided by 6?
Yeah, there's 2 candies in there.
So I have 0.02.
Yeah.
Is that right?
Well, that's what I came up with too. I mean, I feel like the M&M's question is the same as the blood, but just with more choices.
Okay. But I did do it. I didn't finish out the math of it, but. So so is it 0.03? What is it asking us? Do we have to round it up?
Round to
Answer to 2 decimal places? So it's 0.03 then, right? Because it's.
well, I have 0.02166666.
I got 0.0266. Yeah, so 0.03. So the 6 round up.
You got
There's a 1 before the 6.
that's what I got.
What?
0.021666.
Oh, I did not get that. What did you guys divide? I divide 0.13 by divided by 6.
Yeah,
Uh-huh.
that's what,
Yeah. 0.13 divided by 6.
Okay.
Yep, I got the same answer.
1, 3. Maybe my computer's wrong. Oh, yeah, I don't know what I did. Okay, so 0.02 is what it wants, is our answer.
That's what yeah.
Okay. See, I would have missed it if I was doing it by myself. Okay. We better get 100% on this.
We better.
What
At
is
least we can do it. We can do it tomorrow night with him and for sure get 100%.
I know. Well, that's what I was figuring is if we don't, if we get some wrong, we can do it again tomorrow. And
Yeah.
I just like going over it, getting it in my brain, even if I do understand it. Well, what is the probability that a randomly selected candy is green?
well, this is where the 0.16 comes in play.
Oh, yeah, yeah.
And
Okay, 0.16 divided by the 6 this time. Yeah, that was a little trickier one.
You guys are making so
That
much.
out.
My husband being
Okay, so that one,
can't be made up. We all have the same answer. We're doing it different.
0.027, or let's see, 0.03, is the one, 0.03?
That's what I come up with, 0.03.
Okay,
But on
excellent.
my calculator, I have 0.026666.
That must have been what I was doing instead of the other one. What is the probability that a randomly selected candy is not green? So now we're gonna have to take all of them except for the green, right?
Yes.
Add
yeah,
them all up and then divide them by 6. How many?
I did it, and I
Yeah.
don't think it's right.
You don't think it's right? Okay. I'm gonna. So we're doing adding them all except for the green. Am I correct?
Yes.
Then we're.
And I come up with 0.84. Is that what you guys got?
I'm not done.
Yeah, that's what I came up when I added them all.
Well, yeah, but then we got to divide that by 6.
But when you do that, it's only 0.14. I feel like it would and should be higher.
Okay, wait. What is the probability that a randomly selected candy is not green?
Yeah,
So we don't add the green in, so then do we only divide it by 5
5.
instead of 6? The answer is no, can't be 0.84. Yes, it can it? That's is it 0.84?
yeah.
Yeah,
It's
I was just-
0.83, I think. Because you do 0.84 divided by 1.
Divided by 1.
Yes.
Okay.
I mean, it makes sense. I just don't know why we're dividing by 1. Because 84% seems a lot better than 16%. Does that make sense?
But if we just divide it by 1, we're still getting 0.84.
Yeah.
So I feel like that's the answer because when you're changing the decimal to a percentage, you multiply by 100. And then when you get to that, you get 84%. 84%.
I'm a little confused on that one. Okay.
On our homework, with the home states, there's a question that's, I think, similar to this one. It says, according to the table, what is the probability of selecting a student that is not from Utah or California? And how to find that? You added everything except for Utah and California.
Mm-hmm.
But we're looking for.
So do we just
not green?
Add the green? Yeah, so we didn't add the green, which is 0.84, but then what are we dividing it by the 6 still?
What's the probability of getting green? Lisa.
What, honey?
What's the probability of getting green?
What do you mean?
I don't know. I think is 0.14 our answer?
Yeah, well, 0.84 is our answer.
What?
0.14 is our answer?
That's all, I think that's all it could be. I can't figure out.
Gary, come here.
Because the probability of getting green is explained in the chart, which we found out was 0.16. Now, we're looking for what's not green, so we just do 0.1, or not 0.1, but 1 minus 0.16. You get 0.84, which is the probability of not getting green.
What's the probability of a selected candy being green?
0.3.
What?
There's the. So we added them together and divided them by 6, right?
But we don't add the green one, right? We add, so the other ones add up to 0.84, then divide
So
it.
all of this is 0.84.
Brown, yellow, red, blue, and orange added together is 0.84.
Mm-hmm.
So the probability of green is 0.16.
Yes, but it says.
So the
but the
probability
question.
of not green is 0.84.
Because
Okay.
they're green.
What was that?
Because that's but green. He's right. So basically, he's doing a smarter, easier way than we're trying to do it. We're trying to do it.
So our answer is 0.84. We were just a little confused on that one. But that makes sense. Those are all the other.
It's using rule number 3. All of them have to add up to 1, and if green is 0.16, then not green is everything else.
Oh, okay.
Okay,
Did you hear that?
So now we're on the ACT scores. So ACT scores of students admitted to a medium-sized public university in the Western United States were taken from kpex.com. The following summary statistics were calculated. Okay. Half of the observations are less than or equal to what number? Half of the observations? I do not. Okay.
I don't understand that question.
Summary statistics were calculated. Well, so the mean is the middle of the numbers.
The mean is the average.
What?
mean is the average, right? Because median is the middle.
Median's the middle. Mean is the average of all the numbers together.
Mhm.
So half of the observations are equal to or less than 24.
Yeah, because
Okay.
you line them up, because in order to find the median, you have to line them up from smallest to greatest.
Right.
You cross off one from each side until you got to the middle, meaning half of them are greater than 24.
It says equal or less than or equal to that middle number. So that's true. Okay, so now we're on 12.
Okay, so what was the answer for 11?
Well, we think it's 24 because that's the median. So that's the number in the middle.
Okay.
The mean is the average. So we think that all the numbers are either less than or greater than 24 because that's the median. So based on the information on the table above, the top 25% of the students scored above what number?
Okay.
The top. So the highest they could get is 35. That was the top. The quartile, the third one had 27. So does that mean that's the highest percentage? Based on the information of the table above, the top 25 scored above what number? How do you know that's the top 25% though?
Because there's 4 quartiles, and out of 100.
Oh, okay.
Oh, okay.
So it is 27 then? Because
That's the third quartile. That's 75%.
That's 75%.
So, okay. So there's 4 quartiles, and the 4 quartiles need to add up to 100%. So each is 25%. If you go 1 quartile, that's 25%. Is 50%, and then the third quartile is 75%. That means from in between quartile 3 and quartile 4, which is the maximum, there's only 25%. So that's your top 25%.
The 35, the maximum?
Yeah.
Scored above what? But they can't score above that because that's.
No. So your maximum is
They can't score above 27, right? Because
Yeah.
that's to the maximum.
so, okay.
Oh no, my battery's running low. I'm in trouble.
So what I'm trying to get at.
So I don't know. So it's above of the student scored above what number? 27, right? Is that what you think it is? Alicia?
I I think so. It sounds that sounds right. I mean, like I don't know exactly why that is, but that's my problem with this lesson is
Well, because the third quartile, so that would be the top, and the maximum is the very highest they could get on the test.
yes.
And so So that is like 8 from like 27 to 35 is the last 25%.
Yeah.
I don't.
So, I mean, I would agree with 27.
Okay, so we're on the last one then. And I gotta hurry submit it before my battery dies. Which of the following statements is not one of the 3 rules of probability?
Oh.
Oh, remember, I just read those to you and I made my own because I didn't like theirs. So it has to, a probability is a number between 0 and 1.
So that's there.
And it's number, if the probability is high, then the probability is positive, but you can never have a probability that's negative. So I think it's the third.
So yeah, I would say. So we're going with if the probability is high, then the probability is positive. If the probability is low, then the probability is negative. That's the one that's not part of it.
Okay, I'm submitting my quiz before my computer dies. Oh, here it goes. We'll see. Oh. Well, so far, so good. Okay, we missed 1. We missed 2. We missed 3, 4.
4.
Yeah, we got 10 out of 15. I don't know. So we missed, I'm going to have to go. So we missed question 4. What's the problem? I don't know how we missed that.
Which ones did we miss?
We missed question 4 and 5, the ones on the typo blood.
Okay.
And I don't know why. What's that?
Got it. He gave us the answer in the chart.
You did?
Yeah. Like,
Okay, so what's number 4 then? Because I'm going to go back.
because if you look down at what is the probability that it's green, we put 0.84, and we got that one right. Do you see that over there on question 10?
Which number are you talking about?
The one where it says on 17. What is the probability that a randomly selected candy is not green? We came up with an answer of 0.84 because we added them all up, and that was everything but green.
Right.
Now, the one before that said, what is the probability that a randomly selected candy is green? Well, if we just take green, which is 0.16, that's 16% chance of green. In our answer, we have 0.03, which is 3% that it's green. But in the chart, it says it's 0.16, that is green. So the answer must be 16%, 0.16.
Okay. So if you reach into a bag of plain M&Ms, what's the probability of drawing a red colored candy? 0.13, right?
0.13. That's our answer.
13.
On question 8 is 0.13.
Yeah.
Yeah.
And that's dumb, so it's right in the charts. Okay, so we missed those 2. Okay.
Yeah.
The other ones, the only other ones were those ones at the beginning, the typo blood. So we didn't ever figure out the answers for those ones.
4 and 5.
Yeah.
So the probability that a randomly selected person in the United States has typo blood, they gave it to us. It's 0.45. That's the proportion. That's the probability.
And And then, so
And
for 5, then it's
Add up all the ones that are
It's
not
all
on.
it's all the other ones besides 45. So what is that? Well, that's 55. That was dumb. So it's
Real
0.5. Okay. All right. Well, I'm going to end our broadcast.
we don't have to do the homework quiz. That's on our own, right? Or we just do this quiz, right?
Now, let's do this one. So,
Okay.
okay. Adios. This
All
thing
right.
on Wednesday, okay?
Okay.
Okay, I'm gonna redo this quiz and hopefully it works. Okay, I'll put this on the site again.
Okay.
Okay, bye.
Bye. Thanks.
Thank you.
Bye.